goal of this series of learning modules is to educate you, the Mason, in identifying areas that require flashing, the types of flashing typically used for masonry construction, and general guidelines for proper flashing installation. We will outline specific problems that occur when flashing is missing or improperly installed, and the implications for the industry and your employer. Although this module will focus on an introduction to flashing terms and masonry wall flashing locations, it is not a how-to video. This video is part 1 of a 3-part series on flashing for masonry. Part 2 will focus on flashing of cavity walls, and part 3 will focus on flashing single width masonry walls. The technical content of flashing for masonry is based on building code requirements and specification for masonry structures, or TMS 402 and 602, and International Building Code, or IBC. When we refer to the code in this training module, we are referencing these documents. Many of the details shown in flashing for masonry are most perfectly suited for northern climates. In almost all cases, they are still considered best practices. The oldest and most attractive buildings in America are masonry. Whether you grew up in a small town or in one of America's great cities, it is likely the building you most admired was a masonry structure. Masonry structures built today can be designed to appear like centuries-old iconic buildings or match up to the most current architectural design trend. With state-of-the-art engineering and 21st century material science, the time-tested performance of masonry is assured using less material and labor than ever before. Moisture management is a critical component of this new generation of masonry, and this training module, Flashing for Masonry, will show you, the mason, what the code and best practices requires of our craft. Although masonry may have a much higher tolerance to moisture than other building systems, the masonry alone is not meant to be waterproof. The system of masonry, moisture membranes, and flashing must be. Water will enter masonry walls. The masonry assembly must be able to resist deterioration, and water that penetrates the masonry must be prevented from entering the inside of the building. How is moisture prevented from entering the inside of a masonry building? In addition to moisture barriers, masonry flashing. Masonry flashing is an impervious membrane installed in a masonry wall system that collects water that has penetrated the exterior width and directs it back to the exterior through the weep holes. Flashing also prevents upward movement of water by absorption. Thus, flashing can interrupt moisture from the ground. As a trained mason, you install block, brick, stone, and all the components required to complete a masonry project successfully. One of the key components to a successful and functional wall is masonry flashing. Flashing is critical in preventing moisture from entering into the completed structure or causing damage to the components of a completed structure. The wall system must prevent this from happening. Moisture that is not removed from the wall systems will form efflorescence or discoloration in unsightly walls, and likely create callback situations for your contractor to address the disappointing results. Knowing that, trained masons understand that the identification of areas that need flashing and the proper installation of masonry flashing will ensure they are doing the best possible job they can. Flashing details should always be provided to you with a specification and details on the plans. Even though masons should never be designing or selecting flashing locations, understanding the basics of flashing design and details will help as you build them into the wall. In the field, it is possible that you may encounter situations where your training has told you that an area that flashing is typically required by code has none designed. It is important to alert your foreman and employer whether a drawing or specification should be reviewed with the designers to avoid future moisture-related problems. The building code requires flashing shall be installed in such a manner so as to prevent moisture from entering the wall or to redirect the moisture to the exterior. Flashing is required at exterior door and window assemblies, penetrations, and terminations of exterior wall assemblies, exterior wall intersections with roofs, chimneys, porches, decks, balconies, and similar protections, and at built-in gutters in similar locations where moisture can enter the wall. Flashing is a code-required necessity in exterior masonry walls. In fully grouted masonry, flashing is not necessary. In these cases, the wall is designed as a barrier wall rather than as a drainage wall. Flashing functions as a critical component of the overall cavity system. Lack of flashing, or improperly installed flashing, is considered the most common masonry problem. Air, vapor, and moisture barriers play an important role in moisture control, but are beyond the scope of this video. Let's review the general types of flashing, their uses, advantages, and disadvantages. Flexible flashings can include materials such as rubberized asphalt, EPDM, and PVC. Flexible flashings are generally easy to form and join, but may degrade in ultraviolet light. They require full support across cavities and voids, and may be easily damaged. A separate drip edge is typically required with flexible flashings. Composite flashings include copper laminates, copper bonded to other materials, and lead-coated copper. Composite flashings are generally easier to form and join than metal, and are more flexible. They may require full support across cavities and voids, and some laminates degrade in ultraviolet light. Lead-coated copper may require specialized skills to solder. Metal flashings include stainless steel, cold-rolled copper, and galvanized steel. Metal flashings are typically very durable and do not need to be supported across cavities or voids. They likely require solder at joints and can be difficult to form. Galvanized steel and aluminum flashing can be reactive and are typically not ideal for wet mortar. Metal flashings tend to be more expensive than other types. There are proprietary systems available for both single-width and cavity walls that may incorporate some of the materials previously discussed. In some cases, they make installation of masonry flashings much simpler. In all cases, the type of flashing you use on a project is typically selected by the designer. Becoming familiar with the types of masonry flashing and the proper installation techniques ensures you are prepared when they are specified on a project. In addition to the masonry flashing itself, several accessories or requirements are typically needed to ensure proper installation. These include end dams. The installation of end dams cannot be overemphasized. Their purpose is to ensure that collected water is directed toward the weep holes where flashing is not continuous. Such areas occur above windows, doors, and other openings, and under sills beneath windows and at terminations. Often end dams can be purchased prefabricated, or you may turn up the flashing ends into a head joint at a minimum of 1 inch to form end dams. Any cuts should be made watertight with sealant or mastic recommended by the flashing manufacturer. The installation of masonry flashing requires that there is a continuity of protection at inside and outside corners and jogs. Corners can be purchased prefabricated or can be formed in the field with cutting, lapping, and a sealant that is recommended by the flashing manufacturer. Flashing should extend beyond the face of the wall to form a drip. When using a flashing that deteriorates with UV exposure, a metal or stainless steel drip edge can accomplish this. Edges of flashing are bent downward at an angle to form a drip so that any water reaching the drip is shed away. If a drip is not provided, water that reaches the top surface of the flashing can cling to the underside of the flashing and be blown back to the surface of the wall and under the flashing. When sealant is placed between the bottom surface of the flashing and the top of the masonry below, drip edges are not absolutely required for the flashing to perform. Pre-manufactured drip edges are available commercially and should be used with most types of flexible or composite flashings. Often, flexible flashing is attached to the backup at veneers using a termination bar. Ensure that the top of the flashing termination bar is sealed per flashing and moisture barrier manufacturer's recommendations. Weep holes. The type and size of weep holes are typically selected by the architect. Spacing is required to be by code no more than 33 inches horizontally. It is important to ensure that weep holes lay flat on the flashing. Angling weep holes up does nothing but help water collect on the flashing. Mortar control devices. Mortar control devices may not be specified. Although the use is a good masonry practice, and your employer may include it whether it has been specified or not, it is always a good idea to inform the architect that it is intended to be used on the project, and to recommend they specify it in the future. Keep the cavity clean. Mortar droppings can block weep holes, reducing their effectiveness. They also can block the cavity, making it fill with water more rapidly. This increases water pressure on laps and discontinuities, increasing the chance for leaks. Keeping the cavity clean is essential to proper drainage, especially if mortar control devices are not in use on the project. The use of mortar control devices does not exempt the need for clean cavities. Although not technically an accessory, the airspace is a critical part of a cavity wall system. The continuous airspace behind the veneer, along with flashing and weeps, must be detailed to collect any moisture that may penetrate the veneer and direct it to the outside. A minimum 1-inch airspace between widths is required and is considered appropriate if special precautions are taken to keep the airspace clean. Masons should identify the proper locations where flashing is required and ensure that it is properly installed, whether it is specifically detailed or not. Often there is language in the specifications indicating that flashing shall be installed in these areas as well, again whether the drawings specifically show it or not. Understanding the path that moisture will take inside an exterior wall can help in identifying areas that need flashing. If you, as a mason, identify areas that do not have flashing details where it should be, you should notify your foreman and employers to ensure the designer is made aware that an area should be flashed. The mason's responsibility is to build to the drawings and specs and meet industry standards for quality. Flashing and weeps are the most critical element in preventing leaks to the interior of the building. Moisture that enters the masonry wall from above travels downward through the cells of standard hollow CMU or the cavity. The moisture is intercepted by the flashing and safely directed to the exterior out weep holes. Critical locations where flashing must be installed for this moisture to escape include the top of the foundation wall or base of the exterior wall, above the final finished grade, the exposed wall base at intermediate roofs, above the regulator receiver for roof flashing, and above all horizontal breaks such as bond beams and partially grouted, single-width exterior walls. Precast concrete plank are locations that would typically require flashing, as they interrupt the vertical flow of water in a single-width wall. The cavity between the plank and the exterior face should be flashed to prevent moisture damage to the interior space. Flashing should be provided at shelf angles of cavity walls, as well as above exterior openings and below openings. Furthermore, flashing is required at all exterior copings. As said before, work that does not comply with building code will cost a mason contractor money, reputation, and anxiety. Knowing the code requirements for flashing and masonry, implementing them correctly on the job site, and questioning whether they are being met from the design ensures that you, the mason, are doing your best to help your employer remain profitable, and that designers, owners, and code officials recognize the expertise you have developed through training and experience. Completed projects that look good decades later depend on your care when installing flashing, as much as the careful workmanship you perform on the rest of the masonry system. For For a drainage wall system to work, flashing must be properly selected and installed at all of these locations. Under the parapet coping, above each shelf angle, above lintels and below sills, and at the base of the wall. Omit flashing at any one of these locations, and a leaky wall is likely. The cost of replacing failed flashing and other components damaged by water far exceeds any savings realized by skimping on materials, detailing, or workmanship. The Upstate New York chapter of the Mason Contractors Association of America operates in the spirit that, if it's good for masonry, it's good for us all.